Hey guys, and welcome back to another design to manufacture video. Today we're going to be doing something a little bit different. We're going to be looking to create a product from a technical drawing. I've seen this around on the internet lately of tech drawing challenges slash designs, and I figured we'd give this a go. So if you like this content, please make sure you hit like and subscribe for more of this sort of stuff, and feel free to post challenge content to myself so I can get into it and have a go. So without further ado, what we're going to do today is basically a nozzle or a barbed fitting. So you can see on the image up is the technical drawing that I saw online. This one has quite a large thread. It's a large nipple design. So this should be pretty easy for us to draw. It's got a lot of measurements. It's got everything that we need to get going. And hopefully at the end, it's going to look something like this. All right, so without further ado, let's get into it. So because of the cylindrical shape of this object, I'm going to start by creating a profile that I can revolve. So I've gone into my 2D sketch menu, and I'm just going to pan up so I'm looking at my positive quadrant so I can start drawing. From there, I can see that the bottom thread is M52. So that means I want half of that. So I want to come out 26 millimeters. All right. For this video, I'm going to turn off dimensions and constraints, just so I don't have dimension lines coming up everywhere and ruining the view. All right. We're going to go up 45. Then we're going to come in the difference in diameter. So this time it will be 4 millimeters in. And then we're going to go up. We're just going to keep following this process along, moving our way up the bolt. There's a lot of, or nipple. There are a lot of different ways of doing this. This is the way that I prefer. So I'm just going to start at the bottom, work my way up, and come back down and have a nice completed profile at the end. You could do this multitude of ways, and if there's time in the video, we'll have a look at some of those. But for now, we're just going to run it this way. So we're coming from a 44 diameter out to a 80 diameter. So that is a difference of 36 mil. Half of that is 18. Beautiful. Then we're running up 26 mil. All right. The beauty of putting in the measurements each time is it just makes my life so much easier to get this right. All right. Then we're coming in. This time our internal dimensions diameter is 24 for this section. So we've got to come in a fair way from 80 to 24. So that difference is 56. Half of that is 28. Beautiful. Easy job so far. We're going to go up 15. Now to do these next angled sections, the easiest way for me to explain how I would do them is I can look at the large diameter. I can see it is 8 mils larger, so I need to go out 4. That gives me my bottom corner of the triangle. And then I can do the vertical side. All right, and then I can just join the dots together. All right, could do a bit of trigonometry or something fun like that, but we are not going to. We are just going to keep moving along with dimensions we know. It saves us a whole lot of effort, and that way you guys get this video nice and quickly. There could be a quicker way of doing this, but for the life of me, this just works for my brain by just going up and doing each of our sections one at a time. Oh, almost did the wrong thing then. We're going up 15. This is the last of our triangles, or the barbs of the nozzle. All right, from there, I'm just going to pan us up a little bit more. We're going to go up 90 degrees, 20 mil. And that's the top. So now the difference between the inner and outer diameter is 8. So this is another 4 mil wall. And then we literally come straight back down to the start. All right, making sure that it's 90 degrees and making sure that everything looks good. We click here and our shape should become filled. Now we can simply just snip off any lines that we don't need. So we don't need those ones, and we don't need that. And that just tidies up our shape overall. Now there's a couple of other little things that we can do while we're here. We can run some equal distance chamfers on the top edge at 1 millimeter. As if you have a look at the drawing, it's chamfered. It says there a 45 degree, which is an equal distance chamfer, but it doesn't give us a measurement. So I'm going to be happy with 4, because it still gives us a bit of meat to play with. And then we're going to do something a little bit different here. We're going to do another chamfer, but we're going to go a 2 distance chamfer this time. So on this corner, if you have a look at the drawing up in the top right hand corner of the screen, you should be able to see that on the top edge, it goes in 5. Oh, I've got the bottom edge there, 3 and 5. All right. And you can see that's not equal. It comes down 3 and it goes across 5 to make that nice chamfer. We're going to do the exact same thing on that bottom corner. All right. And it's going to go in 5 and up 3. And that's it. That's our chamfers done. And we're ready to revolve this shape. So I'm going to hit finish sketch. Going to hit home. Going to click revolve. Click on this green axis. And you can see that's made most of what we need to. There's a few final steps though, because this doesn't look like the drawing at the moment, because we have a cylinder here. All right, that's a real easy fix, and that'll be the first one we do. We're going to create a sketch, and we're going to create it on this face right here. And we are going to go and create a polygon. This time it's an inscribed polygon, clicking the center point and coming out to the edge, which is 40 mil, which makes sense. That's a radius of 40 mil. All right, and now we have a hexagon. And I'm going to just make a circle that is larger than my shape. That's going to give me a profile that I can extrude downwards to give me that hex pattern. Now, I'm going to show you what's happening here real quick. If I hit enter, you'll see I still got these little rounded sections. All right. That's because I didn't click a small section. You can see if I zoom right in, there's this small little face here that I need to click when I'm doing my extrude. So I need to make sure that I click all of those small little faces. All right, all 6 of them. All right. Now, when I extrude that down, we get that nice bolt head finish with the tapered corners on the top and the bottom. And the last thing we need to do is throw a thread on it. So we're going to go create thread, click that bottom face. It'll automatically go to an M52 by 5, which is perfect. And we're going to make sure we click the modeled button and hit OK. Now, if we quickly throw a section analysis along this side plane here, all right, I can see that my shape is exactly what I want it to be. I can see that that tube is unadhered. I can see that I've got all of the right parts where they need to be. And if I turn that analysis off, everything looks pretty bloody good. All right, now just to make it a little bit shinier, we're just going to quickly go to modify appearance. I'm going to drag a nice brass finish onto it. All right. Just give it a second. Apparently it wants to take a little while today. Drag it in, and we have a nice burnished brass finish. Alrighty guys, so that is literally it for this video. We've taken that drawing at the beginning and turned it into a beautiful 3D model with some rendering. Alright, If you like this content, make sure you like and subscribe. All right, it really means a lot to me. It helps me keep making these videos. And until next time, I'll catch you in the next video.